Yeah, so welcome on the Young Scientist session. I hope everyone had a very good break and rested a little bit because now it's time for some presentations, very interesting presentations. And basically, as a young scientist, what we want to present you today is the Climate-Smart Forestry concept, discuss it a little bit, but also present the ongoing research based on selected participants and speakers. And maybe I will introduce myself at the beginning. My name is Sara Filipek. I'm a junior researcher at Wageningen Environmental Research, and I will be a moderator for this first part of the session, and later on the colleague Jasmine will take over and we will have a panel discussion on the subject with the experts. So, some technical things. All of the presentation will take 10 minutes, and they will follow by 5 minutes of the questions. And if you want to have some online questions, there is also an option. Here is Robert, who will moderate the online questions, so we want to include all of you, also those who are not present here with us. And I think first I would like to start with Lerink, who will explain us the concept of climate-smart forestry and why actually it was needed to make such a new approach. Okay, Bas?
Good afternoon, ladies and gentlemen. Welcome back after a very nice lunch. It's my fair task to keep you awake, to not let you suffer from an after-lunch dip. And I don't think they'll be that hard, because we got something really nice coming up. A young scientist session on climate-smart forestry. My name is Bas Lerink. I'm a researcher at European Forest at Wageningen University in Research, and been involved in CSF for some 4 years. So in this session, I'll explain the concept of CSF. And then afterwards, as Sara mentioned, then there will be presentations from my colleagues and a panel discussion. So let's dive straight into it. So you might be wondering, this Dutch guy, what is he going to say about forest? And you'd be right to say so, because we only have 360,000 hectares of forest in the Netherlands. And that only covers 11% of our land surface. So that's absolutely very meager compared to other European countries, for example. Nevertheless, me and my fellow Dutchmen, we love our forest. We use it a lot, we do a lot of research in it, and that's why we found climate change effects already very early, and we were one of the early adapters of CSF in the Netherlands, and that also everything to do with the presence of Professor Gert-Jan Nabuurs, of course also present here, who really pushed the idea in the Netherlands, set up a network of climate-smart forestry pilots that we're going to talk about later as well. And the need for CSF is very visible in the Netherlands. I'm also involved in the forest inventory in the Netherlands. We published the last round this summer, together also with my colleague Mark-Jan Schelhaas. Many of you know him as well. And here are some striking, worrying results. Here you see mortality on the left, and compared to the previous inventory, mortality, average mortality with cubic meters per hectare per year in the y-axis, has almost doubled in a very short time frame. And also the increment decreased quite a lot. You see here, average increment, cubic meters per hectare per year in the y-axis. And in orange, the coniferous, and in green, deciduous. And really a downward trend. And we see in the last inventory some really great setbacks in Douglas fir, in spruce, in ash. So that's very worrying, and it's clear that there is a need of CSF, which is also the same in the European situation, of course. These are some very dramatic images on the right, Dun de Pila, where forest fires blazed throughout the summer. And also in Spain, of course, you know that there were great forest fires. And here, this picture on the right from my colleague Lewis, with bark beetle outbreaks. Well, you know everything about this. These are unprecedented natural disturbances. And natural disturbances make up for dramatic images, of course. But there are also other effects, climate change effects, visible in the forest that make clear that there's a very great need for CSF. So then the concept of climate-smart forestry. It's an emerging branch from sustainable forest management, really oriented towards tackling the effects of climate change, both on the climate change mitigation side and the adaptation side. And Nabuurs et al. In their paper in 2018 defined 3 main pillars: reducing and removing greenhouse gas emissions, by means of forestry, afforestation. Very important, of course. Adapting and building forest resilience to climate change, but also, and not the least, sustainably increase productivity and the incomes of the forest owners that are dependent on it. So these are the three main pillars, and I think I'm going to leave it here. If you were thinking I'm going to give the whole presentation about the concept and the definition of CSF, I have to disappoint you. I think there were lots of symposia and conferences, a whole cost action about defining CSF, which was very good and very interesting, of course. But this is a young scientist session, and we want to put discussions into action. So I'm going to talk a bit more on the practical side. And that can be done both from a research perspective, so setting up experiments in the field, but also from a more practical side, helping forest managers to implement no-regret CSF measures that we already know of. So how does that look like? Here I took some examples from the Netherlands. Experimenting, here poor pine forests are revitalized with planting a mix of deciduous species to increase the productivity, but also the resilience of these forests to climate change, because these are very vulnerable. But also measuring, you really want to measure the effects of climate change by means of dendrometers, for example, that you see here, point and bend dendrometers, to see the effects of the measures, but also to see the effects of prolonged drought periods, for example, on tree growth. So that's also important. Also monitoring. So if you implement a measure, you want to monitor this on the long term, not only in experiments, but also at the forest owner level. You want to see if when you plant something, whether it succeeded or not. And lastly, you want to publish the results and do a lot on capacity building. So not only forest owners, but also policymakers that you see here as well. Policymakers are more and more invested in forestry, and they make up the national forest strategies. So really important to focus on them as well. This is one thing I'd like to show you. I just said before that Gert-Jan set up this big network of climate-smart forestry pilots. And this is what it looks like, what we've done over the past couple of years. We set up pilots related to forest management, related to afforestation and agroforestry, and using wood in a sustainable way. And here you see them, how they are scattered over the Netherlands. More than 100 pilots. And here on the right, some examples, revitalizing ash forest, which have a lot of damage due to ash dieback disease. Also afforestation in Zuid-Holland, a province where there's really little forest area. And here we use citizen participation to afforest. But also agroforestry is a great success in the Netherlands. People are very enthusiastic about it, and there is a lot of potential for it. And lastly, also wood production next to highways. There is a lot of infrastructure in the Netherlands, a lot of space that we can use for growing trees and growing good quality wood. Another thing that we have set up is a Climate-Smart Forestry network, and there are some members of the network here present. That's very nice. I heard Michel Bozano said this morning that half of the job that you're doing is letting other people know what you're doing, and that's what we want to do here. We want to connect researchers and institutes and to let them show what they are doing, because a lot is going on CSF already in many European countries. But the thing is that we don't talk enough with each other. We don't see enough what we do, what each of our colleagues is doing. So that's why we set up this network to meet some 3 times per year, to do in-depth presentations about our pilots, but also to collect a database and to set up this database with example projects. And this worked out really well, and it's still going on. It's an open network, so if you're interested to join from your country, you'll be really welcome. We have the partners listed here, but we still need some coverage in Eastern Europe, for example. So if you're interested, then please let us know. The website is www.climatesmartforestry.eu. And here you can find all information on these CSF pilots. And I'd like to go through a few of these. An irrigation experiment in Feinwald, some of you may know this, in Switzerland, which is a really great project, CSF project, you could say. It's a bit less on the practical side, but more fundamentally understand how trees react to different climate circumstances. Here, a few plots of pine forests were irrigated, and other control plots were set up where pines were not irrigated. And to put it simply, the trees started growing more in the irrigated plots than they did in the non-irrigated plots. That's simple. But the fascinating thing was that when they stopped, when this irrigation stopped, then the trees that were now at the same dry condition as the non-irrigated trees, they continued to grow faster. So they do have some sort of ecological memory, the researchers concluded. And that was really interesting, and that's really nice information, fundamental information on tree growth and the effects of drought periods or prolonged periods with more rain, for example. If you want to know more about this, visit the website. This is another Aid for Climate project. There are some species in Europe that are really suffering, of course, from climate change, like spruce. But also beech is probably one of the victims in some regions of Europe. And here this is a really nice experiment, and 180 experimental plots in the Apennine Mountains, where they test silvicultural measures to see what's the best measures to create the best beech forest there. Really important project as well, and you have a monitoring system over multiple years. Well, if you want to know more about this, visit the website as well. And lastly, then what do we want to achieve with this? We want to create robust forest ecosystems, resilient to climate change effects, of course, continuation of the ecosystem services that a lot of people in Europe, maybe us all, are dependent on. And of course, we also want to fulfill the CO2 sequestration goals that are set for the LULUCF sector. And if you want to know more about the potential of European forests to store CO2, there's a very nice report here, led by Hans Verkerk, from Science to Policy report. And you can find all information on it there, so it might be a nice read too. Lastly, this is a young scientist session, but I want to thank some fairly young scientists here listed. Mark, Palai, Gertjan Nabuurs, thanks a lot for creating the idea of a young scientist session, from really pushing it. I think I speak on behalf of every one of us that we're very grateful for that. But also Robert, it was a very nice cooperation, and we're really glad that this happened. So, good luck to all young scientists in the room.
Yeah, so now is the time for questions. If anyone from the audience would like to ask something Bas about. The microphone is coming to you.
I have one provoking comment. What is smart is seldom something long-lasting. And that's, I think, my main problem with this climate-smart forestry. Because, you know, always something is smart today, it is not smart tomorrow. So my question to you is, are you really taking these long-term changes which we are really going to face fully into consideration, and not just extrapolating what has been now into the future?
Yeah, well, thanks. That is a provoking question. I think, well, what we also try to focus on, for example, in the Netherlands, a lot of research has already happened for the past 100 years or so. So we also dive into the archives, see some old results from, for example, new tree species that we are interested in. We try to look up where these species are already experimented with in the past decades or so. So we don't have that much time, and we really have to learn from experiments that have been going on already for a couple of years, for decades. So for example, this Feinwald experiment is now 20 years old. And I think in that sense, you have a long time range, and then you'd be safe to say that some things are really smart.
Thank you very much. And maybe you need to come up with a definition of young scientist also, you know? Yes. No, first of all, congratulations, because you have presented it really nicely, so very good job. I was thinking that something that could be useful, and maybe the network that is coming together, the network that you have created for today's seminar, could review also all these different concepts that have been emerging in the last years, like closer to nature forest management, integrated forest management, climate-smart forestry, and to really see, you know, characterize each of the concepts, see which are the overlaps, because also it might be that we are creating confusion for many people, especially practitioners, and it will be within the big framework of sustainable forest management. maybe you know, the young scientists could review, characterize, and see how do we make sense of everything, you know, of all these different emerging concepts.
Yeah. Well, I don't see it really as a question, but more as a remark, but something that we really, yeah, we can really take into account, something that's nice for us to focus on, do more research on, yeah.
Yes, so thank you very much for an interesting presentation. I was wondering, what do you think that climate-smart forestry adds to, in relation to like sustainable forest management that is already like established, and that also includes adaptation, mitigation, and also, you know, the different ecosystem services? And so what do you think is like the new thing with climate-smart forestry that is worth building on?
Yeah, well, I think this adaptation that's already in SFM, for example, there is overlap, of course. But I think this is really needed for meeting the LULUCF goals on CO2 sequestration. It's really also focused on that, and I think that's a bit less in SFM maybe. And we really see it as a goal in CSF, really taking into account what's the additional CO2 sequestration of the measures that you implement. And I see that really as an additional fact in CSF.
That will be the last question. For the back.
Yes, thank you so much for this presentation. My question is, can you describe a little bit the activities of this network, how it works, and what are the benefits for joining, or what is your dynamic in the network?
Yeah, thanks for the question. I think what I tried to explain was that it was really important to share results. Of course, there are papers coming out, but well, not every paper is read by everyone, of course. And here we want to connect researchers that work on CSF and to create better knowledge about what everyone is doing. So what we do, we meet 3 to 4 times a year, and then we give room for 3 or 4 in-depth presentations, so what people are working on. There's a lot of space for questions, there's a lot of space for remarks, for things that you can cooperate with. We even have projects now where people work together from the CSF network. So in that sense, I see really an additional value in joining the network. Yeah.
Thank you, Bas, very much.
Thank you.
For your... So, as we are now introduced to the subject, since we are here in Spain, for me personally, it's the first time here. So, I would like to give opportunity to Núria to introduce us how the climate-smart forestry looks here in Catalonia. The floor is yours.
So, good afternoon, everybody. Thanks for giving me the opportunity to be here today. So my talk is about this regional example, so how we think climate-smart forestry can be applied or implemented here in Catalonia. So to give you a portrait for those that is the first time here, maybe, and you know not much about Catalan landscapes. Catalonia holds over 7 million of people, 7.7 million of people. It's a Mediterranean climate with all that it entails, forest fires and drought. It's a recurrent disturbance every year. It's coming and coming, extreme events that impacting our landscapes. And what I want to point out is it's kind of the general picture for all the Mediterranean countries, and this but it has been especially impacting in our landscapes in the remote, let's say remote or the mountain areas in the Catalan region, is this abandonment of the agricultural activities that has led to this important increase of the forest surface and the standing volume. So these pictures are from a part of the Pyrenees close to Sort, and you can somehow detect forestation, densification of forests, and the abandonment of all these croplands. What that led that we have one third of our forests are relatively young and, let's say, non very well structured forest. So what we have in terms of numbers, just to give you a closer portrait of our forest. 2/3 of the Catalan territory are forests, contrast with Netherlands, and more than 1 million of hectares are wooded. From this forest surface, 3/4 are private. That means that more than 2,000 forest owners are in the arena, and only 1/3 is planted, in fact. We have let's say, well-protected territory. 1/3 of our territory, not only forests, with all sorts of ecosystems, are within the Nature 2000 network. And the last number I want to point out here is this increase in the standing vote volume in the last 25 years that we could see. The laser is here. So from the second national forest inventory to the fourth, there has been close to twice of the meter cubits in standing volume. So if we are, as we say, a country of forests, what are we doing with our forests? So the forest sector only represents 0.06% of the GDP here in Catalonia. And even if forest growth we estimate close to 3 million of meter cubits per year, only 30% of the annual growth is harvested. Most of the reason relies on stands on the management costs that are quite expensive in our territories because of the orography and the accessibility, but also because of the timber price are relative, or let's say relative low. Most of the transformation industry focus on low added value products like pallets. And in fact, we know, and this is calculated, that only 80% of the annual wood consumption here in Catalonia comes from local forest. So we need to change a little bit the dynamic. And why we need to change that? Well, Catalonia as a region in Europe, as many other regions and countries, it's called to meet the objective of all these, let's say, regional policy frameworks at the European level, but at the regional level too. So from the mandate from the Generalitat de Catalunya, the Catalan government. We have all these strategies calling to achieve the climate neutrality by half of this century. But here in Catalonia, we have recently proved two important strategies that really focus on forests and forest ecosystems: the Catalan bioeconomy strategy, the ABC 2030, with specific goals that target forests, but also the natural heritage and biodiversity strategy of Catalonia, also for 2030, that both have to meet in a way to really manage the landscapes in a way that we meet many goals. So we need to upgrade the management of how we manage our territory. We have to do that in a period of increasing risk and uncertainties due to climate change, natural disturbances, socioeconomic factors too that will change. We are called to meet all these agreements and policies, and new ones that will come. So in a way, we know we have to promote this resilience here in Catalonia, a list of these agroforest landscapes for the provisioning, the sustainable provisioning of a multiplicity of forest ecosystems. So if we narrow, but if we focus our perspective on forest ecosystems, we said, okay, we need this multifunctional and climate-smart forestry to meet all these objectives. So what we understand by climate-smart forestry here, in contrast to a business-as-usual scenario or approach, let's say, there's not big mysteries here in definition. Then the next slide will give more details, but we propose to implement, as a climate-smart forestry here in Catalonia, given our framework, a progressive increase in the demand for wood and the managed surface, but coupled with a change in the silvicultural practices to mitigate climate change as a main target of climate-smart forestry, as Bas presented, but also to fulfill other goals that are as important as carbon sequestration here in the Mediterranean landscapes. First, and very important, to reduce the risk of forest fires, of extreme forest fires. We are not already talking anymore about large forest fires, but extreme forest fires. Improve the vitality and resilience of the forest stands, ensure the production of blue water, very important in water stressed environments as our country here. So focusing a lot on the forests that are here in the north, but on top of the rivers to ensure the production of the water that arrives to the rivers, to sustain high levels of biodiversity and promote, it's something, let's say, new in this climate-smart forestry for us, to promote the production of carpentry products with greater added value and a longer lifespan to really impact also on the carbon balance. So this is the first proposal to bring the climate-smart forest concept on the ground, on the land. Is this close to nature silviculture, as I said, combine the increase of managed area with a new silviculture. It has to be a productive silviculture that provides natural and renewable wood products that bioeconomy demands. Should relies or be based mostly on continuous forest cover in a way to reduce the area of regeneration cuts. Has to bring to the arena high recurrent but low intensity interventions. Needs to promote mixtures. What else? And then be really local in terms of a detailed selection of operations at the tree, even at the tree or at the group of trees levels, and work a lot with light management. So use of natural mechanisms to, let's say, save or reduce the need of silvicultural interventions to maintain the structure of the forest that we target. And of course, this needs a constant biodiversity monitoring. It's something that it's really in the basis of all this silviculture when we talk about close to nature silviculture. And all that, we need to do that to meet a multiplicity of goals. Okay, this is, let's say, the framework, different levels. And as someone asked it, okay, but what will be if this is smart enough for the future? So we are thinking that today this is the best or one of the best solutions. It will work for the future. So we are working with a projection system that includes a set of climate-sensitive individual tree models to simulate forest dynamics under different scenarios of management, of forest management and climate. And it has kind of a modular structure that includes the evaluation of different wood and not wood ecosystem services like biodiversity, water, fire risk, biomass, carbon, wood products, mushroom yield. And we are working, so we have adopted this division, this strategical territorial division in the framework of the first action plan of the bioeconomy strategy. We are working with the Catalan government. This division of Catalonia in homogeneous landscape units, and we are working in some of them with this projection system to start exploring the effect of climate-smart forests in contrast of the business as usual. I now give a really short pass of 4 ecosystem services, just to give you a sense of what the projection system is capable to do. Here's carbon, so we can calculate or estimate the carbon balance, including the emissions and the stocks. Here is still missing the substitution effect, so we are still working and evolving the tool to really be able to estimate our contribution to climate adaptation or climate mitigation. We have worked with a model, a Niedrig water balance model with coupled or jointly with farmers to be able to estimate the production of blue water by 2100, by the end of the century. Here we see in the northern parts the effect of climate-smart forestry adding more blue water to the rivers. Trees consume a lot of water, at least here in the Mediterranean. Here it's the same picture, but for wood. There's another picture, or could be another picture, about different product, the different assortments wood goes to. And there's a few numbers that we are working with, some indicators we are still developing on biodiversity related or forest biodiversity. And all these four and other ecosystem services we are working with, what stands for. So the idea, maybe in 1 or 2 years, we can really explain to you or expose to you all the chain, all the framework we have in mind to develop. But we are already working with this type of multi-criteria optimization tool to put everything on the pole and work with stakeholders, with local stakeholders that help us to weigh these different ecosystem services and be able to explain or to quantify the trade-offs between different ecosystem services. To the end, be able to establish this payment of ecosystem services here in Catalonia. And yeah, and I think that's all. Thank you very much.
So now we have time for questions for Núria. Over there on the back.
Georgi Safona from Jon's office. As I am from bioeconomy unit, I have economic questions a little bit. So you mentioned that actually forests in Catalonia provides only 0.06% of regional GDP, right? So I have a question, how that was measured? So what was included in it? Was only timber included in this measurement and at current price? Or that was diversity of different non-wood products, services, etc., 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 which is relevant for annual production of Catalonian forests, as I would imagine. Second thing relates to value of forests. So not only production, but actually keeping a lot of carbon in wood stands or in soil and so on. So that's a big reservoir of carbon, as well as biodiversity, recreational services, and
multiple.
Did anybody value that values of forests? So you have flows, you have stock of values. So it would be interesting to measure it, compare it with this 0.06% of regional GDP.
To increase this 0.06, exactly.
At least understand, is it really that minor, negligible number of the role of forests for the region, or it's wrong interpretation of the role of the forest in the economy, economic sense? And last point is regarding management of that. So would you think that there would be some regional solutions to enhance interest of forest owners or investors in forests to do something about expanding forests, improving management of forests, for example, based on regional carbon, price or pricing, or some tool like in New Zealand when private owners can trade with carbon credits and they are interested in investing in it. Or that is not working for the region. Thank you.
Okay, I'll start from the end. There are already some projects, some pilot projects working with the evaluation, the assessment of the potential of forests of carbon stocks, not only on the above ground, but also on the soil, to start designing this payment for carbon. As here in Catalonia recently, they implemented a tax for our cars, and we pay if your car contamines, so more, you pay more. So the same thing, but the reverse. If your forest stocks more carbon, you should receive more. So there's already a pilot in the preparedness to start designing this payment for ecosystem services in this sense, the ecosystem service of climate mitigation through carbon storage or sequestration. That's first thing. Second thing, there's not yet a complete overall evaluation of all the ecosystem services, boot and not boot, market and non-market ecosystem services in Catalan, so that Catalan forests provide to us. I think it's an important challenge, not only for Catalonia, for many other regions, to really put a price to all the ecosystem services. But there are some starting with the easiest one. There's a project with the Water Agency of Catalonia, Agència Catalana de l'Aigua, that are already thinking, and a live project, Climate-Smart, that are already designing this payment of ecosystem services for water production. This is each agency has already its focus, but they are working on the heads of the watersheds with the forest owners of the head of the watersheds to see if there's a way to implement this payment of ecosystem services to at least to maintain the provisioning of water. So there are some startings, but there's still the need of put everything together. I think that's all.
Yeah. Thank you very much. We need to jump to another presentation, but thank you very much, Núria and Bas, for introducing us to the subject. It was a bit of the preparation what is coming next, which is also very exciting, since in front of us, in front of me, there is 5 young scientists who agreed to present for us their work. They were selected based on the grant, EFI grant, and as the first person who would present for us, it will be Isabella Hallberg's Marek, who will tell us a little bit more on what is happening, like how we can bring the CSF to the local level, which is very interesting because sometimes the theory doesn't meet the practice. But Isabella will tell us something more about it, so come.
Yeah, thank you, Sara. Yes, so I'm very, very happy to be here and present this paper to you, bringing climate-smart forestry down to the local level, where we try to bridge the gap between this more scientific definition of climate-smart forestry and bringing it down to practice and trying to understand what it means to local stakeholders in Sweden. But first, a short introduction of myself. So I'm a PhD student in forest management at the Swedish University of Agricultural Sciences. And I'm planning to defend this spring. And I'm very interested in the science policy interface, specifically how we can adapt forest management to climate change, local conditions, and societal needs, and to do this, bring in this more holistic perspective on forest management. And I'm collaborating both inter and transdisciplinary, so I'm working both with researchers from forest sciences, social sciences, and humanities, but also collaborating with local stakeholders in Sweden. And my main supervisor is Professor Annika Nordin at SLU. So, as you heard, Climate-Smart Forestry is this new science-based forest management concept which aims to integrate climate change mitigation and adaptation to promote forest contributions to people and global agendas. So our question was, what does this really mean? Because it's quite abstract. So what does it mean in practice for the people living here in this landscape, for the people managing the forest, for the people using forest for different purposes? So we conducted forest excursions in Sweden together with local stakeholders, one in northern Sweden and one in southern Sweden, and we included forest owners, forest industry, environmental NGOs, hunters, but also people that are, recreating in the forest and also involved in local development. And we asked them, what do you think that climate-smart forestry means in this context? And also, what conditions do you think are acting as barriers or pathways for implementing this in practice in Sweden? And during these discussions, we recorded the group discussions, and the stakeholders also wrote individual reflections on the topic, and we analyzed it qualitatively using grounded theory. So some of the results then, both stakeholder groups had quite similar ideas on what climate-smart forestry is characterized by. So they thought that it included active management to promote forest multiple values and use in different places. So, and this includes actively managing to promote biodiversity, for example, not only they experience that today a lot of forest is only left unmanaged, but they see a lot of problem with ingrowth of spruce, for example. That is something that needs to be dealt with more, but also actively managing for production and also recreational values, and also thinking about forest recreation in a broader sense, maintaining campsites, trails, signages, and those kind of things that really help draw people out in the forest. And they also thought that it included a more diverse management, where we use more a broader range of tree species and also management methods to both mitigate environmental risks, climatic risks, but also financial risks. And to also adapt the management, both to the ecological conditions of the sites, but also the social conditions, how is the forest used on this place, by whom, and how can we consider that in the management as well. And they also thought that we need to consider landscape perspective more, especially in terms of these issues that need to be dealt with on a landscape level, and to find collaborations for dealing with them, such as pests and pathogens, but also biodiversity, water management, etc. And then they identified these conditions that could either work as a pathway or a barrier, depending on how they are handled. So I'll give you some examples. For example, value chains for forest products and services was a big topic in the north, especially as the stakeholders thought that there were very limited markets for forest products. So if you, for example, would like to have more deciduous forests, then you can only sell the timber as pulp, and there are not really any buyers for timbers. So they thought that we need to develop better, more diverse value chains in northern Sweden, but also value chains for example, berries, so we can also make use of what is already produced, but that is not really used. In southern Sweden, they were very much focused on the management of ungulate population, because in southern Sweden we see this sprucification of the landscape, where we're getting more and more spruce as a result of very dense ungulate populations. So they thought that this was a very important issue to deal with, to be able to diversify the tree species selection. And then there were several other factors, so you can read about it in the paper, such as forest ownership and taxation policies, local knowledge and experiences, forest multiple use, and local collaboration and networks. And then when comparing then the definition we see in the literature of climate-smart forestry to the definition by these local stakeholders, the definition in the literature is very broad and inclusive. It could include multiple interpretations and be used across Europe. But it can also promote practices that would not be considered climate-smart locally, and thereby, as it is so broad and inclusive. Whereas these local articulations are locally desirable and actionable. They are based on the experiences, like past experiences, but also future visions of these local stakeholders with knowledge of this landscape. But it cannot be used as templates in other settings because it is tailored to these specific contexts. So based on these results, we developed this more conceptual figure for how we see that the climate-smart forestry concept can be further developed in Europe, where we see that the definition in the literature could act like as a common definition that could provide a point of departure for local articulations. But then we still need these local articulations for it to be applicable and relevant on the local level. And they can also be strengthened by the collaboration between different local places, as was also reported in our paper, where the northern stakeholders have learned from the southern and vice versa. And this can in turn then refine and strengthen the common definition. And we see this as more like of a iterative learning process and also exchange between science and practice. And I think that this can really strengthen both the practice and science of climate-smart forestry. Yes, so lastly, I would like to acknowledge my co-authors and also the local stakeholders for participating in this study, and also Formas for funding it. And thank you all for listening.
Thank you very much, Isabella, for a very good presentation. And now it's time for the questions. No? Not yet. Wait for the microphone.
Thank you very much for your presentation. I'm wondering, because we were looking at the definitions of climate-smart forestry, I guess you know that there is a definition for climate-smart agriculture that is provided by the FAO, that says it has to be a system that is viable from an economic point of view, mitigate climate change, and at the same time is resilient against climate change. Did you integrate that in your studies?
Yeah, so in this, when starting out this study, the focus was to mainly see okay, so how do they think that we need to mitigate and adapt to climate change? But when starting to talk about these issues, you really need to try to figure out what do we want to use the forest for, because that's also central to how we will adapt forest management to climate change, and also what kind of mitigation strategies will be used. So while the initial idea was to focus on mitigation and adaptation, we ended up being more in this question of what do we want to use the forest for, and how do they see their role in the future. So
Thank you for this interesting research and for sharing it with us. I actually have a methodological question, and I would be really interested to know more about how you collected the data, in the sense that, have you provided the stakeholders in the forest with a definition of climate-smart forestry, or have you asked them, for instance, what do you think climate-smart forestry is, or how did you relate it back to the concept then?
Yes, so actually this was a part of a longer collaboration process together with these stakeholders, where the aim was to find out how they would like to adapt their local communities to climate change. And then the forest was only a part of this. But actually out in the forest, we asked them, okay, so what risks and opportunities do you see because we visited different examples of forest management methods. So we asked them, what risks and opportunities do you see with this kind of management, both in terms of climate change, but also in terms of, for your local society, or lokalsamhälle, as we say in Swedish. And then like this actually, snowballed to this bigger discussion on like what we want to use forests for, but also the barriers and pathways for implementing this. So that's why we also, the data analysis became more inductive in that sense. And we started out with this very broad question that then entailed, all of these other things as well. And we also recorded these discussions with dictaphones, and like solving that kind of issues is also challenging sometimes when doing this kind of work.
I wonder whether you are including potential consumers or urban consumers as your stakeholders. And I am asking this for several reasons. One of them is in the morning we heard that EFI is trying to link forests and the development of cities and the structure of cities. And I wonder whether you had the opportunity to include the potential consumers, or whether we are considering that possibility in the cities. Yeah, so of course we're all consumers of forest products and also these stakeholders, but if you think about it in terms of like people working with construction, then the answer is no, they were not included in this particular study.
Thank you very much for all of the questions. Of course, there will be time later on to ask more Isabella about the subject. But now we need to move forward for another presentation. And now will be more about the natural disturbances. So Joyce Romeiro will introduce us to the CSF Norway, which investigated the risk of bark beetle under the changing climate change. So come. The floor is yours.
Hi, everyone. I'm Joyce Romeiro. I'm a PhD student at the Norwegian University of Life Science. And my project is Climate-Smart Forestry Norway. And today I'm going to talk about bark beetles' risks under climate change conditions. So, as you may already know, and I think you know because it was already said, one of the goals of the Climate-Smart Forestry strategy is to adapt forest management to build more resilient forests against natural disturbances. And of course, the Climate-Smart Forestry Norway project is doing the same thing. However, realistically, we can only think about adapting our forest management once we know the risks we are facing. So, talking about the bark beetle outbreaks from recent years. In 2019, Czech Republic, we had 14.5 million cubic meters of the harvested spruce timber was damaged by bark beetles. And in Germany, in 2019, 31.7 million cubic meters were damaged by insects, but that's mainly bark beetles. And then in 2020, for those two countries, bark beetle damages increased as well. For Czech Republic, it increased from 14.5 to 14.9, and in Germany increased from 31.7 to 43.3 million cubic meters. And then in 2021, it was a better year for us, not for the bark beetles, because weather was nicer. But in 2022, this year, we just had a huge draw and heat waves. So that's probably favoring bark beetle outbreaks again this year or next year. In no way in general, it's almost sitting pretty in that aspect, but southern Norway in the 70s had 5 million cubic meters of Norway spruce damaged by bark beetles. That was on the 70s. It lasted around 8 years or 10 years, that outbreak. So, can I have that water? So, it lasted around 10 years. And after those 10 years, it kind of died out. But then now we are seeing, this is from last year, bark beetles in the south of Norway. The numbers have reached their highest level since '97. And now bark beetles in the south of Norway have 2 attack periods each summer. That means they're able to produce 2 generations every year. But still, with those numbers, we have never had a estimation for the potential bark beetle risk in Norway. So that was the goal of my research, to test a bark beetle model in Norway, dealing with analyzing probability, damage intensity, and risk of bark beetle, dealing with both current climate and climate change conditions. So first I needed to know which model I could use, which model would be best for the Norwegian conditions or for the data that I have. And then I did this review, and I analyzed the 7 bark beetle models. And I chose the one from Seder 2009. I don't know if Seder is here. Okay. Because it was more suitable for large-scale forest management planning. It needs simple inputs, estimates probability and effects of damage, which was what I needed. And it has the possibility to address climate change. And the model from Seder was created for Austrian conditions. And I used the same parameters because I had no way to reparameterize that model. But of course, the inputs are for Norwegian conditions. So the inputs used are Norway spruce share, stand age, annual temperature, and annual precipitation. And then I was able to do the bark beetle annual probability, damage intensity, and risk for current climate, and bark beetle probability, damage intensity, and risk for climate change. And this is one of my results. This is a risk map for bark beetle. And the dots are the NFI plots. And this zoomed area here, it covers the most important regions for the forest sector in Norway. That's Trøndelag and Innlandet is here in Wageningen. And what we can take from this map is that 36% of the productive forests in those regions are at risk of losing from 0.1 to 2 cubic meters per hectare per year. And, and this is for the current climate. And this is for climate change. Each graph here is by region, so this is Trøndelag here, and then Innlandet and Wageningen. And maybe you can't see that, but with climate change, probability of bark beetle attacks will double. This red dotted line here, it splits the graph in two. So the gray area is the probability done with the historical climate temperature and precipitation. And these are the precipitation. This is the precipitation done with the climate models. And what we can take as one of the most important things in those graphs are the peaks in probability. So with climate change in Norway, in Trøndelag, we're going to have 16%, but we also have some smaller peaks, around 15%. And in Wageningen, we can have around 21% of probability of bark beetle attacks. So what is important to see with those results is that we need to adapt our forest management. Sanitation logging and salvage logging are already done when we have wind throw or the initial stages of bark beetle. But it's interesting to think about using mixed forest stands instead of Norway spruce monocultures. We could start doing that now in Norway. And replace Norway spruce trees with Scots pine when it's possible. I think Ditlev will talk about that. So I'm looking forward to hearing what you have to say. Thank you.
Yeah, so now is the question time for Joyce.
Thank you for your presentation. Jiří Novak, Forest Research, Czech Republic. Only one note about the situation in the Czech Republic, because it totally depends on area of Norway spruce stands out of ecological distribution of spruce stands. So we have still a relatively large area with Norway spruce stands in lowland and in middle elevations. So it's area with the highest problem with bark beetle calamity. So only one note about this modeling and about this factor. It should be included also to the some future ideas.
Interesting. So you're saying that it needs, it's mostly the outbreak is mostly on the outside the natural. Okay, all right. Interesting.
I mean, maybe that goes a bit in that direction. The figures for Germany that you showed, so the Statistical Bundesamt, they're always far behind. We are counting with something like 180 to 200 million cubic meters of damaged timber only for the years 2018 to 2020. And this is certainly underestimated. And it definitely didn't stop 2021 because there was a lot of timber out there. So I think up to now, I would say we are rather into 250 million cubic meters. So this, what you have here is just the tip of the iceberg that comes up in the official statistics.
Yeah, that's the official, okay. Yeah. And they were saying that it's actually decreasing, that it decreased in 2021, but you don't think so? Okay.
Because you were showing us that it's based on a modeling approach, basically trying to find out the probability of the bark beetle outbreak. So in the selection of your data, you show the NFI data, but what are the description of the stands, if they are mixed stands or this is only the stands in the plots that the Norway spruce is present and the rest is ignored? Because there was the middle part of Norway where we didn't observe any risks, any real risks of the outbreak.
You mean for the current climate? Well, what I use is not what the model uses, because you can use like from 1% of Norway spruce, but I decided to use at least 10% of Norway spruce. So yeah, it covers also the mixed stands. And I'm not sure why Trondheim, I think, right? Why inland? Yeah, okay. But I'm not sure. Maybe we don't have so many because that's a very mountainous, full of mountains region. So then after some altitude, the Norway spruce doesn't grow. So we probably have less stands with Norway spruce or like productive stands there in that region. That might be the reason. But it's good that you mentioned that, then I can discuss that in my paper.
Are there any more questions for Joyce? Okay, then thank you very much.
Thank you.
And now we still gonna stay in Norway, but we will discuss more of the conversion from the plantations to more of the mixed forest. So Ditlev Revenlov will tell us more about that. Please join.
Thank you for that, and thank you for your presentation, Joyce. It reads perfectly up to mine. So my name is Ditlev Revenlov. I'm a postdoc at Copenhagen University, and thank you for allowing me to come today and present on my research topic on converting Norway spruce plantations on poor sites to species better suited for the future climate. As you already heard, Norway spruce monocultural plantations are especially problematic outside the natural distribution range, where they are suffering from a wide range of instability problems projected to be worse in the future climate. Despite these problems, there's been planted 6 to 7 million hectares of Norway spruce plantation outside of its natural distribution range, primarily on sites naturally covered by broadleaf vegetation, especially beech. On the other hand, we have not seen a similar increase in other conifers considered to be stable in the face of climate change, such as silver fir and Douglas fir. You can say the need for conversion of these exotic Norway spruce plantations is especially large on sites where we at present have almost 100% Norway spruce. And a good example of that is the heathland plantations of Western Denmark. Here there are specific challenges in the conversion as well, where we have areas with late frost in May and June, very hampering for the establishment of most of these shade-tolerant but climate-resilient species, which typically have low frost resistance. So how to do this? Well, in line with also the current transitioning to close-to-nature forest management in the region, which Paul Larsen has been very much the man behind, the best thing to do it is to plant under a shelter. However, it is complicated how to optimize this shelter underplanting process, because the shelter trees are also unequal competitors for both light as well as soil resources compared to the small underplanting. And also, if you do increasingly heavy shelter wood thinnings, you also increase the risk of windflow. So that leads to the research question, which is, when converting Norway spruce stands on poor soil, what effect does shelter density have on the development of underplanted beech, Douglas fir, and silver fir? And the investigation has been done for this area in Western Denmark here. So what was done? These shelter wood treatments were installed in a 60-year-old Norway spruce stand, 18 meters high, which is in our region considered the stage at which we really see an increase in the windflow risk afterwards. You have to imagine this area was actually, if the picture had been taken 60 years before, it would have been all Atlantic heathland. So quite a lot has happened in this area. This setting with a spatial area of around 38 square meters per hectare was then reduced to a wide range of shelter densities ranging from 10 to 36 square meters per hectare. And these are just to give some illustration from different settings visually. And following that, the area was soil preparated and underplanted with these target species. The experiment was then followed for 19 years, during which in some areas of the experiment there was windflow taking place, altering the originally planned trajectory of shelter density down below 10 square meters per hectare, you can say. So coming to the results, we first look at mortality. If we look at the left graph here, that is the mortality 2 years after planting. And if we first look at the results for silver fir and beech, it's interesting to see that the mortality is actually kind of constant along this range here, from 10 to 36 square meters per hectare. On the other hand, when we look at Douglas fir, we quite clearly see a strong increase in mortality, especially when you get above 20 square meters per hectare. Here, similarly, the situation 11 years after planting. I only show this graph to show you the difference between, because here 11 years after planting, we have some results where we have lower shelter densities than 10 square meters per hectare. So I'm just showing this graph to kind of illustrate the difference in how silver fir and beech respond to this low shelter density environment, despite that they are both considered very shade-tolerant tree species. And we clearly see that there's quite a large difference in the result of silver fir and beech, silver fir being much more sensitive to low shelter density. And this, I know is a bit weird estimate annual mortality, but this means 100% mortality after like 15 years. Moving to the results for height growth, we see that first of all that Douglas fir is maybe not so surprisingly the species that shows the highest height growth across a wide range of shelter densities. We also see that it's a species where the growth is mostly dependent on shelter density, showing a wide range of variation in growth from the highest to the lowest shelter density. On the other hand, we see a species like silver fir where there's very little variation, and we also see that actually after this here, silver fir doesn't increase its growth anymore. And I think also maybe I should add to the previous slide here that you can see the trajectories here for 2 years after planting and 11 years after planting appear to be quite different here for these two settings, but that is a consequence of that our linear model was not completely able to take into account the precise trajectory of that mortality curve. So actually these two lines are more going like and very steep from 10 square meters per hectare. Otherwise, these two curves would look quite similar to these two curves here. Just to clarify that. And this is just to show some visual examples of what I've been talking about. If we first take the left corner up here, we see establishment of beech at a shelter density of 27 square meters per hectare, where beech is clearly grown very little. On the other hand, if we look at the picture here in the bottom left corner, we see that the setting for where we have a shelter density of around 17 square meters per hectare, where beech have grown more than twice as much. Finally, we have here to the right, we have a setting where, and maybe I should just add that all these pictures are taken 18 years after the initial underplanting. The setting over here, we have an area where there's been windflow, and there's originally been planted mixed silver fir and beech. Interesting to see there's no, there are two silver firs here left, long dead. All the conifers you see here in the understory is naturally regenerated Norway spruce. On the other hand, we have some beeches that have survived the loss of shelter. Many are browsed and frost damaged to a bushy shape, but there are also individuals that manage to get out of the critical height zone, so to speak. So, reaching a conclusion on our investigation. For the optimal underplanting of silver fir, we recommend 15 to 20 square meters per hectare. You can say 15 square meters optimizes its development, but it also comes at a higher windflow risk. So for many settings, 20 square meters is more optimal, which can then be reduced later on. And in any case, the shelter should be kept for a long time with silver fir, more than 20 years. In regards to Douglas fir, the other extreme on the line, we recommend very low shelter density, starting from around 10 square meters per hectare, and then reducing it to something around 6 square meters per hectare afterwards, from around 6 years after planting. And shelter should be removed quite fast, probably actually just after 10 years. Last one, we have the beech, which shows some kind of intermediate behavior between Douglas fir and silver fir, where 15 square meters per hectare of shelter density seems to be an appropriate shelter density. And it also shows some flexibility in regards to whether you keep the shelter or whether you strongly reducing it fast. And some other important results from our study is, I would say, that it really highlights the benefits of mixed forests when converting to these climate-stable but sensitive species. For example, in the case where we see windflow, some species handle that better than others, clearly. And of course, these results also, they have to be, in actual forest management, they have to be looked at in together with data on shelter economics, obviously. Thank you.
Thank you very much for the presentation. It was very interesting and very practical, actually. So a little bit different what we heard. Are there any questions in the audience?
Yeah, thank you. Obviously, you had some impact of browsing. Did you have some control areas that were fenced off to see what the impact of browsing is on this success rate?
Oh yeah, I might have forgotten to mention that, but all areas were browsed, oh sorry, not browsed, fenced in the investigation. All were also browsed, but that's another story. Yeah, all areas were fenced, although where we see windthrow, obviously there was maybe half a season or so where the fence was down due to falling timber and so. But only like in half a year periods where the fence was down, I would say. Less than a year for sure. They were quite good at checking it. But yeah, it's a major limitation to conversion here because there's so many red deers.
Question for you. Because you showed us that there are differences between the mortalities between the species. Can you explain a bit more why do you think it's caused? Because normally, I think from the scientific point of view, it's that it's related to the species growth and what is the most suitable for them. So can you explain us more the difference why beech actually did quite well in comparison to fir?
Yes, I think the results can be summarized as that silver fir needs shade, beech tolerates shade, Douglas fir needs light. But the reason why it is that I think in as also some tropical plants do, I think I mean sometimes you also see wide-ranging mortality in silver fir on sites where there's not so much late frost simply because of sudden exposure to higher light regions. So I think it's just I think it just has a higher tolerance for those low light, or higher need for those low light conditions than beech. That's one thing, and then also, of course, you could say the interaction in this study with browsing, which is impossible to get around because the deers can also jump over this 1.6 meter fence, and even though we are in a conifer-dominated plantation here, silver fir is still targeted more by deer than beech. Considerably more here.
Actually, the follow-up, sorry. Because at the moment you show us 3 species, but there are any plans to actually introduce more species to that mixture that would work? Is it something already ongoing, or there is the idea of that?
Yeah, so presently I work on this EU LIFE project, Forest Fit for Future, which is a more practical angle on this, you can say, where we have 5,000 hectares we convert in Danish forestry, where we then have a monitoring program on that. And you can say in that regard here, our target species are mainly Douglas fir and grand fir and beech as well, to have some native species brought in these conversions. So I would say grand fir would be is a species I'm most sad about. It's not included in this experiment, I would say.
Then if there is no any further questions, I think we can move to another presentation. Thank you very much again, Niklas. So we are talking about the forest management. So now I think it's the time to talk about wood products. And Nicola Bozolen will tell us more about how to find the link between the wood production and also the industry. Come.
See if it works. Okay, it works. Okay, so hello everybody. My name is Nicola Bozzolan, and I'm a PhD student with the double affiliation with the Wageningen University and Joint Research Center, the GRC from European Commission. From the picture, you can, and also from the introduction from Sara, thanks. You can understand I will explain a bit about my PhD. and especially focusing on the harvest wood product. So my main research question of this PhD is basically to understand to which extent climate-smart forestry, and including the wood products, can enhance the climate mitigation effect of the European forest sector. So this is an ambition question, and we thought to break down in the 3-step. So, well, climate-smart forestry is an approach, and we will apply some strategy and some measure for the future. So we will need some scenario analysis to do this. So let's start from step 3, and we go backwards. Scenario analysis is nice, but we thought the best way to do some scenario analysis is by developing by using some module. And so now we will couple, as we'll explain later, 2 different, we will couple like the harvest wood product model with a forest resource model. This model has to be based by some information. So we thought, let's start from this. Let's start to understand, first of all, what's happening in the wood industry, and have an overview, and we can play around with some scenarios. So to do this one at EU level, time efficiently, we have divided Europe in 4 ecozones, and for each ecozone we select a country which represent the ecozone. So we select Spain for the Mediterranean area, and we select France for the oceanic area, and then Germany for the continental, and Finland for the boreal. For each country, we study the wood flows across the wood flow from the industry. And as you can see here in this Sankey diagram on the right side, we represent the wood flow. I will give you a quick overview of this diagram. It's basically the green part represents the raw material, the orange part represents the flow of the product, while the yellow, the recycled and post-consumer wood, and the red one is the bioenergy, wood that goes to bioenergy. This is Germany. And we did this one for all the 4 countries to have an overview. Here you can see the 3 main stock, so paper and paperboard stock, the wood-based panel stock, and the softwood stock, which is the IPCC approach. You calculate the carbon that goes inside the stock. So based on this, we create a model to forecast which will be the future one, and to see if we change this flow, basically, for example, if we move some fuel wood to material, or if we, for example, we have an energy crisis and we move more wood, which is designed to go to the material, to the fuel wood, which will be the effect of the carbon in our country, in the country of the case studies. And this is more or less the result. I will just give you a quick overview because we have time constraint. But of course, the main result is that the different countries perform differently. So, climate mitigation strategies should be tailor-made for each country, and there is not like silver bullet strategy that is fit for all. And of course, like material-based industry give much more mitigation benefit rather than energy one. So here in this graphic, the material one is indicated with yellow line, and the blue one is the opposite. So when we use like bioproducts, for example, for energy and not for material. And you see that there is quite some difference between all the scenarios, but the magnitude change. Since we see, okay, this is a nice result, but why we have this? Why we have this behavior in the countries? And so we say, okay, it must be something linked with the regional use of wood. And we say, okay, we need to go deeper on that And so we say, okay, we need to use spatial explicit model and see what's happening at regional level. So the step 2 is the development of the harvest wood product model. But for doing this, we need like one side, the forest supply, and from the other side, we need the demand, which will be based to the industry. So regarding the wood supply, we will use efficient space, which is a forest resource model, which is used in our team in Wageningen, and is able to provide us like, well, it's based on the National Forest Inventory plots, more or less 270,000 national plots, and it's able to provide us like this wood supplies in a spatial explicit way, giving us the information regarding the wood species and the DBH. So that's really useful because then we can use this innovative forest industry database, which have been collecting with several colleagues and also with Resonate colleagues. So this is a new database composed by more or less 6,500 facilities around Europe. It looks like a pizza, but it's quite complex and long work. And in green, you have like the sawmill facilities, in red, the bioenergy plants, and white, the pulp and paper. And for each of these plot, for each of these point, we have the location, we have the capacity, so how much wood is going to this capacity. And so we can basically couple the regional supply with the regional demand. That's the, well, that's the objective. Okay, so that's what's look like, more or less, the merging of the two database. And here we can see, for example, in green we have the forest plots, so the wood supply. Here, for example, we have a sawmill, and there I remember we have the capacity. So if we take, for example, this region divided for the different facilities we have in the territory, we could, for example, detect undersupply, regional wood resource efficiency of, for example, if like sawmill byproduct can be exchanged in, well, with the closest wood-based panel industry. But it's also more interesting, I think, at least for me, is that we were speaking a lot of mixed forest and how will change the composition of our forest, no? But so how will change the wood utilization in our forest? So this is quite fundamental, in my opinion, since now, like, while forestry in Europe is using a lot of sawmill, a lot of softwood, but we will go to a future where we have like more mixed forest and more mixed, more hardwood. So how will change also the utilization of our wood in our regional level? And that's exactly the step number 3. So we will try to tackle this question, which was at the beginning complex, but then breaking down, maybe we can have like some answer. Is basically putting together the first step we saw, so the analyzing the recycling part and then the stock with a regional view. So doing this, probably we'll be able to see which is the best strategy to to fight climate change and to enhance the mitigation effect of the forest industry. Well, thanks. That's.
Wow, even double males, just in case. Thank you very much for your presentation, and I hope there are some questions maybe in the audience. Yeah.
Thank you. Giorgio Matteucci, National Research Council of Italy. So I think this is an important point, so to take the industry into consideration. So I think we need also that side of the pie for climate smart project consideration. So maybe the question maybe is more general, more for the maybe general debate. A climate smart forestry would be a more complex silviculture. This means cost. So on one side, how those costs can be evaluated and then which side of the pie bring those costs. And another issue, actually, normally the target is larger trees or more mixed, and so you mentioned now this may change in the market. But for example, larger trees, are the sawmills ready to process larger logs? No, because sometimes it is also, so all these consideration should be, I mean, how you can reflect on these issues and maybe also the others in a general debate.
Yeah, indeed, that's a really relevant question. So, is the industry ready for the change we would like to see in the forest to push this, mitigate this climate smart into the forest? But then, how we react? I don't think we have an answer now. I don't know if the industry is ready to do this. For sure, speaking with some experts, I have noticed like this how do you say, this worrying for the future, and there are already big group, especially like sawmill, they already like start thinking which is the strategic plan for future. But yeah, for sure this is something that is to take in account. For us, at this point, we start to thinking at the allocation. So we have some DBH, we have some guidelines how industry is using wood, but how the future the industry will use wood, we don't know. Especially because it's, as you mentioned at the beginning, strictly connected with cost efficiency. So if something is more rentable, if it's more profitable, at certain point in the market in the future, then we have a completely shift of the commodities.
Valérie Merckx, so from EFI. I have a question around the way you've been integrating into the model the import and exports of wood, so both from different countries, but also regionally, because I sort of get a sense in your presentation that you matched somehow, or you made an assumption somehow that in a dedicated area, the crop, what's harvested goes and is transformed on site. Am I right on this or not?
So, okay, it's not here anymore. But so for the slides where you have the plot and the sawmill, you mean? Yes. So that's actually a really delicate question because, well, of course, import-export is not linked with boundaries. So, for example, in that case, in a case where we have like a sawmill that is close to border, probably we have like, sometimes it's possible, but we have like the supply, it's out, well, it's over the border. So for now, what we are considering is like to work at small scale, at regional level, and the idea is to see if the regional supply, like if we take like a radius of, I don't know, 100 kilometers, if the regional supply of that facilities is enough, and if it's not enough, we think to say that is import, what is missing, or is export, what is not, is the oversupply. But that's really important from a modeling point of view. And for now, the idea is this one is a simplistic approach.
Hello, Anthony from CTFC. Congratulations for the presentation, and the model looks very useful also for us that we are working at the regional or state level, just to create a link between the modeling and the type of work we do from the regions and the states with the modeling across Europe you are doing. Only a comment, are you using representative cost, harvesting cost, logging cost figures, or transport to the first transformation industry and representative price ranges in each region? Because that, of course, will give you an idea of potential for mobilization, and I think that will be very interesting. Thank you.
So cost, so I think it's super interesting linking this harvesting with the cost. However, as we know, like cost is well, the economic side is really difficult to model because there are like several variables to take into account. So for now, for my project, we will not implement the cost, but there is already like almost done package done by the colleagues in the team in Wageningen that they take into account like the harvesting cost divided like, the harvesting cost, the slope, the distance from the sawmill, like it's already all planned, but for now we will not integrate soon into the module. But for sure in the future will be done.
Thank you, Nicola. Thank you for this. I have a question for you about how you validate this output of a model in terms of the maps that you produce. And I'm asking you this because sometimes models surprise you and make you think. Sometimes models make no initial sense for the good and for the bad. And I was surprised to see, for example, some of your regions there that you put the balance between sawmilling or pulp mill that you saw doesn't fit with what we think the regions are about. So, and there could be many reasons for this, but how do you validate what you are doing?
How do I validate like the data I collect for the industry, or how do I will evaluate the match between the industry and the
outputs of your models?
Yes.
You validate the inputs and then you validate the outputs.
Yeah.
And by the final results, how do you plan or to validate before you start using it in let's say, policy support, for example?
Yeah. So, well, from the input data, I will validate using the national database of Hallstatt, because of course it's already, well, the data. So the data collection has been difficult, as you might understand, since a lot of industry wouldn't know to share the data. So the validation is also a bit tricky part, because in some cases we found like an biggest number in the capacity of and the production, rather than like at national level. So the validation will be based on Hallstatt at the beginning, and that for the regional level we will see if we can like find a better way of validating. But for now, maybe with some regional expert, as we are like already in touch.
Yeah, perfect. Thank you very much again.
Thank you.
And last but not least, Maximilian Schult will present us about the forest management strategies and substitution effect of the wood products. So please take the floor.
Well, thank you very much, Sara, for the nice introduction, and good afternoon, everybody. My name is Maximilian Schulte, and I'm a third-year PhD student at the Swedish University of Agricultural Sciences. And I will talk a bit about climate change, mitigation of Nordic forest management strategies, and about substitution effects of wood products. And I want to divide my presentation into three parts. First, I want to give you a short introduction into my PhD contents and state the objective. And then the second part will be a summary of my second PhD article, while the third part of the presentation will be about the next steps, so to say, or the current state of my research. Here you can see a framework of what my PhD is all about, and this could be framed to be in line with this so-called system perspective of the forest sector or of wood product systems. And we can see the division of these wood product systems into the forest system and the techno system, and then the sum, so to say, from all the different carbon and greenhouse gas fluxes that occur within this system. And what I do within my PhD is I account for these, and I do not only account for these in one specific point in time, but I apply a time dynamic principle to this. So I am able to apply it to whatever time horizon I'm interested in. And in addition to this, I do not only assess the greenhouse gas fluxes, but also I calculate the atmospheric temperature change due to the greenhouse gas balance, in order to enhance the understanding of time dynamic climate effects of or climate change mitigation synergies and trade-offs within climate-smart forestry systems. So I want to show you a bit about what I did throughout my second PhD study. And here you can see a simplified framework of what I just showed to you. And here the so-called system boundaries started by modeling the forest system, and this was then extended into the so-called techno system, where we assess the greenhouse gas fluxes of the harvested wood product carbon storage in the form of carbon dioxide and the residual fossil emissions of the forest industry, the value chain emissions, and last but not least, we then account for the substituted avoided emissions. And I state this here in this, in this framework from the forest to the end use in form of a supply perspective, because I will get back to this at the end of the presentation again. But how did this second study now look like? How did the forest system look like? Here we can see that the study was based on 3 different regions across a climate gradient from north to southern Sweden. And we were having 4 different forest management scenarios where we increased or decreased the rotation length or the harvest intensity by 20% respectively. And this was then benchmarked against a certain reference scenario, which was then based on a business as usual rotation length according to the different regions and based on the forest reference level based harvest intensity, all based on National Forest Inventory data that was processed within the Forestry Decision Support System Heureka. Well, the output of this Heureka was then used to model the so-called techno system. So Heureka provided the input for this, and what I did in this study is I developed or modeled then detailed breakdown into these different harvested wood products from the initial harvest volume, which then allowed for the calculation of different carbon storage potentials of all of these different harvested wood products. And in addition to this, it also allowed to calculate product-specific end-use based displacement factors or substitution effects whose weighted average, the so-called market displacement factor, amounted to 0.6 tons of fossil carbon that was then avoided with every ton of biogenic carbon we were having in these different products here. So how does this now look like when we take all of this into one picture? So in green, the forest system, then in yellow, the fossil value chain emissions and the harvested wood products, and in purple here, the substitution effects. Well, an example of that you can see in this picture where we see the greenhouse gas balance of these most southern Swedish region for a time horizon of 100 years, where we see the longer rotation scenario as compared to the reference, and we can see that there, due to the prolonged rotation, there is an increased forest carbon sequestration happening as compared to the reference, which, however, due to the more older getting general forest age class distribution, then has a certain offset effect in the subsequent decades. And we can also see that these, this breakup into the purple shaded substitution effects, they do not offset the forest carbon dynamics as we see in this picture. And in order to show some trade-offs that may be already apparent from just looking at this picture, I included here some numbers. We have then, based on a 25-year time horizon, an average net mitigation potential for this entire region of Kronoberg of about 1 million tons of carbon dioxide equivalents. But this then diminishes to only 200,000 tons of carbon dioxide equivalent per year on a long-term time horizon. If we even broaden up the scale of this picture here and take into account all of the different regions, a picture like this here may emerge when we look at the different climate metric, namely the temperature change. Here we can see in this figure an average across all of these 3 different regions, and for each of the scenarios that I was mentioning as relative to the reference, which in this picture is the 0 line, independence to varying assumptions about the substitution effects. And we can see that the longer rotation as well as the decreased harvest scenario, regardless of how strong or weak, how big or small we assume the substitution effects to be, they lead to an additional climate cooling effect, whereas the increased harvest and the shorter rotation scenario rather lead cumulatively into a climate warming effect. More information about this is available as this study was recently published. And to use the last minutes of my presentation, I would like to shift over to the current state of my research, where I focus about the demand aspect of wood product systems and the climate effect assessment. And here we see the slide that I showed you in the beginning again, and the title is Switching the Perspective. And this is because these setups of these modeling approaches, which are quite frequent, they account for substitution, which is, so to say, merely limited by the supply of the additional harvested wood products. But in reality, as Nicola also pointed to, there is actually another factor, and that is the demand. And in that sense, in terms of a modeling framework, the idea is to switch the setup and start with a concrete example of a harvested wood product, and then backtrack the implications in terms of greenhouse gas fluxes over the products until the forest system. So from the end use to the forest with a demand perspective, where then the substitution is limited by the demand of this product. And this is what I do currently apply to the future demand of Swedish multifamily housing, where we see that throughout the past years in Sweden, concrete here was the dominating frame material used and wood only comprised a minor share. At the same time, we have figures or numbers about that there is an additional demand or requirement of about 460,000 flats in multifamily housing in Sweden. And given the demographic development of the Swedish population until 2050, this will increase to 1.1 million. And in our reference projection, we would then remain the relative share among concrete and timber-based buildings the same. And then we would introduce a scenario where we say, well, what happens actually if there was a total phase out of all the additional concrete buildings already by 2030? So the gray line here goes to zero, while the brown would add up to the entire stock, so to say. And the question then is, well, from a system perspective, what kind of climate change implications would that pose in terms of the substitution and the remaining parts and ultimately the forest system? And I have preliminary greenhouse gas balances on this here, where you see that the substitution effect leads to a negative, so a saving balance in total. But you may also wonder about the forest land, and well, this is also something I wonder about at the moment. I received just values for this weekend, but I could not put them into the presentation. So how this may look like, I'm looking forward to discuss with you throughout these days. Thank you very much.
Yeah, thank you, Max, for a very good presentation. Are there any questions? Yes,
Bart Muiskei, Leuven. Very nice presentation, thank you very much. And I like it very much that you bring in this demand curves to have better substitution scenarios. But what I wonder is a bit about your assumptions. For example, for substitution, what is the energy mix? Is that something constant over time? You have to take into account that also concrete will be made with other sources.
Yes.
We speak about this window of opportunity of substitution that there is now in the next decade. So did you take that into account? And also maybe something on the assumptions you made for forest management. How do you introduce new forest management? Do you assume that all of your stands in a certain region all at the same time get longer rotations, or how do you introduce that? Thanks.
Well, to relate to answer your first question, clearly there are so many assumptions behind these modeling approaches in general. And when we talk about substitution effects, due to the decarbonization efforts regarding certain policy schemes, etc., there must be a phase out of the fossil emissions, and therefore it is actually desirable that the substitution effects become minor in the future. However, we don't know how this will look like. In my first PhD study, we included a marginal electricity mix that we were replacing, which by every decade, the amount of renewable energy we were replacing with this, it was just one product that we were looking at in detail, it got more cleaner, the energy that we were replacing, so that the energy-related substitution effect actually had a complete phase-out. It was not given there anymore. And to answer your second question, well, the forestry modeling here is based on Heureka. And Heureka is a very complex instrument by itself that takes into account the corresponding time requirements, how such a change would then require in the landscape.
Congratulations, very good presentation. I don't know if you know, but actually you may have a good idea, a good source of information to incorporate expected demand. Do you know the project by Sila and Anders Ross in SLU, where they are actually estimating, they are going to estimate the expected demand of buildings made out of wood in the next years. So I don't know if you are already considering that into your model, because then that could definitely enter very nicely, and you could have a really nice supply curve that could fit the demand that is expected.
Yeah. Well, I built the model in the way that I can easily adjust it, so maybe this is an idea for another scenario that we can introduce.
Yeah, thank you for presenting interesting work. In your forest modeling, how did you include disturbances into disturbance risk?
They are not included.
Yeah, then it's not helpful.
Yeah, well, this is, I have to admit, this is a clear shortcoming, but we also did not make use of any RCP 4.5, 8.5 scenario. So we were because Heureka provides you the option of including an RCP 4.5 scenario, but it is a bit problematic because it solely artificially increases the growth rate while not accounting for any disturbances that may also rise. And therefore we thought, well, it may be a more conservative approach of switching this climate model within the forest simulations off. So we disregard favoring effects, but also problematic effects. Yeah. So yeah, this is a shortcoming, I admit.
Yeah, thank you very much for all of the questions. There will be, of course, time to ask more if you are more interested. And first of all, I would like to thank all of the presenters for the great presentations. I think now we are really aware of where our research is going and that we have really great people for that. And for now, to have some 10 minutes break, I would like to invite you for some coffee, and then we'll continue the session with the panel discussion on climate-smart forestry. Thank you.
Hello, everyone. Let's start the continuation of our session. Hello, good afternoon. My name is Yasmin Parato. I'm a junior researcher at EFI. I'm part of the BI unit in the Climate-Smart Forestry team in UNSU. And as a younger researcher, I'm very glad to be here today. And I will be the one moderating this panel, which brings seniors and young researchers to discuss about climate-smart forests together. Well, I will start my presentation our panelists. Then I will ask them, each one of them a specific question. And then after that, we can address questions coming from the audience. So, our first panelist over there, it's Dr. Mariana Hasegawa. She's a researcher of the Climate-Smart Forest team at European Forest Institute. She has a bachelor degree in forestry and a master and a PhD in wood sciences. She has over 15 years experience in research in forest management, forest resources, and wood products, and also covering many forest types, including subtropical, temporal, and boreal forests. Thank you very much for being here, Mariana. Our next panelist is Dr. Margarida Tomé. She's a professor at the Superior Agronomy Institute in the University of Lisbon, where she teaches forest inventory, forest modeling, and forest management. She also coordinates research groups that have a strong focus on the transfer of knowledge of end users by developing technical applications that might integrate and make research results more useful. Thank you for being here, Margarida. Our next panelist is the PhD candidate Marco Pataca. He is a researcher at the Wageningen Environment Research. His focus is on assessing the resilience of European forests and exploring synergies between climate change, mitigation, and adaptation strategies through forest management. Marco holds a bachelor in forest and environmental science at the University of Tuscia and a master's in forest and nature conservation in Wageningen. Thank you for being here, Marco. And last but not least, we have Dr. Antoni Trasobares. He's the General Director of Forest Science Center of Catalonia, and he has a doctorate in Forest Science and Economics degree from the University of UNSU, and a Master in Forest Engineering from the University of Lleida. His professional career has been related to research, technology transfer, and applied projects in forest management and the environmental in general. Thank you for being here, Anthony. So for the first part of this session, we will start by exploring a little bit further the climate-smart forest concept and gain some insights from the different perspectives from across Europe on how climate-smart forests could strengthen the role of forest and the forest sector in climate change mitigation. And to start that, and considering the amazing presentations that we have and also the discussions, I would like to first ask Marco, in your perspective and regarding your work, how could climate-smart forests enhance climate change mitigation in forests and the forest sector? And how is that different than sustainable forest management, close to nature management, and other approaches? So Marco, please.
Yeah. Yeah? It works? Okay. I'm not really used of these things. Thanks, Yasmin, for the introduction. And indeed, very relevant question. We also have been discussing it earlier. I think it's very important to say that there is, like, it doesn't make much sense, in my opinion, to talk about mitigation if it's not together with adaptation. Because without the forest ecosystems being adapted to the changing climate, the mitigation effects, it's most probably not so relevant anymore. They are not going to mitigate much. And we have been seeing a lot of examples in the last years across Europe where not paying maybe enough attention to adapting the forest to the changing conditions really decrease the productivity and like together with all the consequences that this means related to the carbon cycle. So that's very important to say, I think. And about the difference between climate-smart forestry and continuous cover forest or close-to-nature forestry, I think we really need to see it climate-smart forestry as an holistic framework. And as Bas mentioned earlier, it's founded on 3 pillars, which do not include only the forest systems, but climate-smart forestry really looks at the socio-ecological systems as a whole. And we have been seeing this in many of the presentations of the young scientists just before the break, that it is really important to look also at the societal aspects and and of course together with the forest management. But close to nature forestry, it's really it's almost I mean, at least in my opinion, it's almost a silvicultural regimes, or it's very oriented to the forest management itself, but it doesn't look at the other connection with the social, socio-ecological system indeed. So I think, I hope I addressed the questions.
You sure did.
Maybe it would be nice also if people from the crowd here interact and share their opinion about this.
Yes. So thank you very much for that, Marco. Now, for having a more national perspective, I would like to ask Professor Margarida, in the context of Portugal. So in Portugal, you are facing increased climate change impacts. Also, the forest sector in the country has significant areas of highly intensively managed forests, such as plantations and monocultural stands. So I would like if you could describe for us how climate-smart forests would look like in this context.
Thank you for the introduction, Yasmin, and I'm glad to be here and to share some of our experience with you. And Yasmin asked me about the monocultures and the forest fires in Portugal. In fact, if we would be able to get rid of the forest fires, it would be a climate-smart forest, but unhappily, it's very difficult. And the problem is not only having monocultures, because this is not the big problem. I will give you an example. In Portugal, we have the country divided by a river, that is the Tagus River, and in the southern part of the country, we have very dry and hot areas. And in the northern part of the country, we have a lot more of precipitation. And where do the fires occur? In the north. Okay, so, and the main reason is because we have different socio-ecological systems in the north and in the south. In the south, we have large properties where agriculture is mixed with forestry. The 3 species are different, but the 3 species are not the most important in what concerns forest fires. We have agro-silvopastoral systems in the south. We have more people living from agriculture. And so it's a completely different system. If we go to the north, we have a very complex structure of property, very small properties. A lot of the landowners don't even know where is their land. And due to long-term abandonment of the areas, nowadays the status of the forests is terrible. It will be very difficult to restore those forests in a way that it will be profitable for the landowners. So what do the landowners do? Nothing at all. They just wait for the fire. So we need a new governance system. If we want to solve the problem, we have to find new ways to do management at the landscape level, because forest management, to be smart, cannot be focus on stand level. It has to be to take into account larger areas. That's my main message. I can tell you that in the north, other than the structure of property due to the abandonment of the agricultural areas, we have very large continuous areas of forest, very large. In one county where we had a project in the beginning of the 20th century, they had 7% of forestry. In 1955, they had 35% of the forest. In 2017, when they had a big fire that burned 85% of the county, they had 90% of forest area. So we need to find ways to create a mosaic that is more, that is better to fight the fires, and I think this is the climate-smart forestry against forest fires in the country. I had something more, but one thing that I should also mention is that, because Yasmin, you talked about monocultures. The monocultures are not the problem, because in Portugal we have monocultures in the south and monocultures in the north. Most of our forests are all planted, not plantations, because according to the FAO definition, plantation is different from planted. They are all planted, even our cork oaks, they are all seeded, but by man. And in a study that my colleagues working with fire did, the forests that are more prone to burn are the mixed stands. Why? Because the mixed stands are originated by areas that burned and regenerated with mixtures of pine and eucalypt that are not managed, and so they are the ones that burn. And the intensive monoculture plantations, for instance, they do not burn because they are managed, okay? So climate-smart forest is not easy. Forestry is very complex, and in order to solve the problem, we have to be aware that nature is very complex. Sometimes it does not happen what we are expecting, and I enjoyed very much to listen to Bas, I think it's Bas, the first speaker, that talked about the need to monitor, okay? So we have an idea of what is smart, and we implement, of course, but then it's very important to monitor, to see if nature has replied as we were expecting, or if we need to adapt our decisions and to improve them.
Thank you very much. I see there is a question in the audience. Let's make one question. Okay.
Sorry, that's just a very brief question. I am Sara Filipek from Wageningen Environmental Research. So you mentioned that you need the fires. Are you already doing some prescribed fires that are managed by you, and you will try to use this method to get better forest cover?
Yeah, I'm not a specialist on fire, but there are a lot of prescribed fires being done, but mainly at experimental type. I don't see landowners doing prescribed fire, but it's being done. But with the climate that we have in Portugal, the window of weather where we can do them, you have to be expert on that, but we think it's one good way to fight against the fires. Yes.
Thank you very much, Margarida. Now, for a more regional perspective, I would like to ask Anthony. Here in Catalonia, we are in a highly forest area, as we saw in the presentation earlier today. And I would like to ask you, how do you see the integration of climate-smart forest, bioeconomy, and other mechanisms that seek to reach climate neutrality in Catalonia?
Okay, thank you. This is a good question. As my colleague Núria already presented, we are at the 30% of the annual growth and surface being managed. Currently, industries do not produce much added value products, and that relates to the question I also asked to the colleague with the scenarios of supply and demand, that the cost is rather high. We have topography contrast, we have not very dense road network, and the price has been remaining the same for 20, 30 years. And so that means that in many occasions, the cost is higher than the price of timber, and when you bring it to the industry part. So for changing that, I mean, it's a big project, and several factors should be considered, but maybe we could think about three levels. One would be, of course, what we are talking about here, doing science and working with the modeling, with the monitoring, so to provide science-based scenarios to change this tendency and to provide a clear information for forest managers, what could be types of stand and landscape structures and regional state of forest, which is closer to resilience, to biodiversity conservation and the fire risk, or minimizing extreme wildfire events. That would be, we have the science, we have tools, and we are working on that, first level. Second is how management is implemented. I mean, that's not easy, because if we come from a forest sector which is in this situation, where there has been much abandonment and the margin along the value chain is not much. So we need to think that, okay, there can be approved forest plans, but after that, you need someone in the forest marking the trees in the right way and implementing silviculture in the right way. And the close-to-nature forestry, it was also said before, it's not going to be cheaper, the current ones. It's going to be more detailed, and there will be selection criteria, and so it's, let's say, good silviculture. So to face that, I mean, that would be the sort of supply, or what we should do in terms of forest and forest management, and for pulling from that and making that possible, one would be the bioeconomy. I mean, we have been working very hard for the start of cross-laminated timber production and other products which provide more margin to the cost, to the price of timber, and to the dynamics of the sector here. And tomorrow we have a great example here with all this construction. And there is a paradox that Catalonia is the region in Spain prescribing more wood-based buildings. But we bring timber from our colleagues in Basque Country, or now in Galicia, or even farther from Austria. There is a small company in the Pyrenees, and now in 1 year or so, one of the big sawmills will start producing that, and that will be a big change. So for covering that, bioeconomy is one way, but the other, and I think relates much to this close-to-nature forestry, would be the payment for environmental services. I mean, we need to balance, we need to optimize mitigation, but much of the interest is on the adaptation component. And here in Catalonia, for sequestering 1 kilo of CO2, we need 4 cubic meters of water, because the way it rains, there is much evapotranspiration. That colleague that several of you may know, Carlos Gracia, was explaining that recently. So that's one factor. If we have no water, no matter we have more standing biomass, more or less alive in the forest. And the other component, of course, for example, it has been said, is about forest fires. So if we have big forest fires, all this carbon will go back to the atmosphere. So we need to identify the provision of those ecosystem services in more balanced scenarios, and we need to work on these economics, the valuation of ecosystem services in well balanced estimations. We are working on that to complement this modeling for the multifunctional smart forestry, and implement that. I mean, both things, the bioeconomy and the payments for environmental services should go together, because that will be the way. I mean, if owners and forest managers know that these extra payments are provided, if you do the silviculture in the right way and that is certified, then they will have more interest to do it in such a way. If it's only a legislation, it will be harder.
Yeah, that's for sure a very complex situation. Thank you very much for the nice answer. And now for a North and also a global perspective, I would like to ask Mariana, how do you see climate-smart forests in the North European perspective compared to other regions in Europe? And given that you have worked as well in the North and in the South America, I would like to ask you, why do you think that Europe can learn and benefit from the topic from other parts of the world?
Well, perhaps I can start from the end. Europe and North America, they are very similar in many ways. So the forest types, they are similar. Some of the species are not that different. Even the way the forest is managed or forest management approach. So there are some similarities in that sense. Your question is really good because how can Europe benefit from that knowledge? Well, in Canada they have, there's this interesting project, it's called Smart Forest, and it's coordinated by the University of Quebec in Montreal. This project is actually a network of plots for monitoring purposes. So they are focusing on collecting data that is very detailed, so it's really high resolution monitoring plots. They are collecting the data on climate, on environmental variables, and also how these variables have an effect on forest and forest growth. So this is something that is interesting because they are doing it Canada-wide. And I think it's not their work. It may not be too different from what Bas presented with the CSF network. So I think this idea of having highly detailed data so they can assess and see how forests can adapt to climate change. I think this is something that maybe is not something that Europe can benefit from that, but there are similarities. And then as Margarida was answering about the situation in Portugal, so in Brazil they have this interesting initiative which is related to agroforestry. So there's this group that works closely with small landowners, and it's especially targeting the degraded lands. So the situation that, yes, sometimes you explore the land and it becomes totally degraded. So they are trying to implement agroforestry with these small landowners, where they really want to understand the purpose or what the landowners want when it comes to crops. So for example, if the landowners say, well, the idea is to have trees because I'm going to sell this wood to this company, or I want to have these trees where, for example, I can produce cacao and sell that, and then a mixture with agricultural crops, or maybe have some animals. So they are really trying to work with these people and understand their needs, and at the same time do it in a way that they restore these degraded lands, so they become, well, they can function again as an ecosystem. So I think this is something that I'm sure there are initiatives similar in Europe, but maybe this is something that could be implemented in some regions where it's not being done, as Margarida had said.
Yeah, thank you very much. That's very interesting. Now, I would like to ask questions from the audience. So please raise your hands and the microphone would come to you. If you would like to ask a specific person, just state the name of the person before and then ask your question. But otherwise, it's a general question, that's fine. So let's start now.
Thank you very much. I just want to make a comment because of a question that was done before. With regard to the prescribed burning, there is a project that was called Open to Preserve that involves, it was a Interreg SUTOE project that involves Portugal, but the north of Portugal, Spain and France, testing and evaluating the fact of prescribing farming with very excellent results. Alicia was also, USC was also participating on that. And as far as I saw, in the south of France, close to the frontier with Spain, this is an activity that is currently done every year by farmers. So there are examples of that in Europe. Thank you.
Does someone else have a question?
Thank you. Yes, I have a question maybe for Margarita, but also for all. You said that Climate Forestry is complex, Climate-Smart Forestry is complex, but why so complex? I mean, if you think preventing fires, if you think no biomass, no fires. So it looks rather simple, the solution. So what is it about is so difficult to really deliver what research says that should be delivered?
Please, Margarita.
As the question was for me, I think it's complex because nature is complex. And our knowledge about nature is not as complete as we would need. That's why sometimes we act the best way according to our idea. And then what happened is not exactly what we were expecting. And suppose we want to have forests that sequester more carbon, but we also need to have all the other ecosystem services. We need to maintain biodiversity. I usually say that we have an unsolvable puzzle. So I put everything that we want from the forest in a different shape, and then they do not fit together. So our life of foresters is made out of trade-offs. We are improving one issue, and maybe we are making harm to another one. That's why it's so complex. If we are just thinking about increasing sequestration, so I would plant everything, increase the area of forests, then I will sequester a lot of carbon. Then I have more fires because I have the continuity of the areas. Where is the best combination, the best mosaic? I don't know. So I think that we have to act carefully, discuss with other people, and because I think that, you see, in Portugal, the politicians, they always think they solved the fire problem. Every year we have a summer that is not so hot. We solved the problem because they bought some more Canadairs and did something. And the first way not to solve the problem is not to recognize that it exists and is difficult to solve. Because then we will start to study and find the ways to solve it.
If I may add, it's not only complex on the proposal, the calculation, the trade-offs, also complex in the implementation with different stakeholders. I mean, here you know it well. We organize a meeting with green infrastructure, biodiversity conservation people, and jointly with fire prevention or even wood production. Then, I mean, it will not be a straightforward process, but this type of approach will help for sure. And then, of course, there will be the governance component. So start from the easy part of the problem, and then where the trade-offs are, find reasonable solutions.
In this context, I would like to ask Marco, as your expert in disturbances, how do disturbances are dealt under the Climate-Smart Forest scope? And also, could the need to adapt to disturbance and climate change affect wood use and product markets?
If I should answer with an easy answer, it would be in many different ways. Of course, this is rooted in the fact that there is so much difference in different systems across Europe and beyond, of course, and not only ecologically, but also culturally. And the land use is very different. And for this reason, it's very difficult to to say how climate-smart forestry would address a specific disturbance type, because depending on the place and the context, it might be many different ways. And some places, I refer to Europe because that's the boundary of the system I work on, and I know a bit better. But different places have knowledge that is already exists about disturbance fighting, like in the Mediterranean, in Europe, in the south, there is a lot of knowledge about fire. And I think it's very important that this knowledge and these perspectives are shared. And here is the added value of a climate-smart forestry network is to really embrace in a conversation with people that are not used to face certain disturbance, but might be used with the climate change and and changing environmental conditions. So I think this is very important, and also very important is the fact that the solutions should be tailor-made for the different context. We have seen, like in the example that Margarita brought up for fire in Portugal, which is very close regions. They have totally different contexts, both in the cultural use of forest and in the forest conditions. But for sure, there is a way, like there are ways where knowledge can be applied in different contexts, and it's very important that that this sharing of the knowledge will take place more and more. I forgot the second question, so maybe you can repeat.
How these adaptation measures that would take to avoid disturbances would affect wood demand and products and.
True. Well, they for sure will. The forest industry in Europe, it's a very traditional industry that is culturally rooted in a few types of woods, and is very well developed on these types of woods. And for this reason also, in certain regions, these species have been promoted highly since many, like hundreds of years. So in that sense, the industry is very well adapted, and of course changing because of disturbances. We all have seen pictures throughout the presentation of bark beetle outbreaks in Central Europe and so on. The industry will need to adapt, but yeah, it's difficult to have a perspective on that, you know. And once again, it's very important to keep open the conversation also with the private sector for this reason, because I mean, we can, as a scientist, we can study a lot of case studies and see how moving from a monoculture to mixed species would work or how the dynamics would behave. But in the end, yeah, it really, like the private sector really has a, like it really pulls the change. You know, like in many places where spruce in Central Europe was totally damaged, people are planting back spruce in the same places because this is the demands, and this is what the market wants. And so it's easier to, if you do not talk on a broader scale, and there is no interaction, it's easy for the single forest owner to make the easiest choice. And on the other facts, I also, on the other side, I also would like to point to the fact that disturbances do not only will affect the forest value chain for the damages the direct damages, so the millions of cubic meter damaged, but also for the displacement in the planned forest management. So we know that in the last 20 years, each year, 15% of the total European harvest is salvage logging. And this 15% is around 55 million cubic meter. And this, of course, has a direct impact on the markets. But also, this salvage logging, it takes up space of the forest enterprises. So they have to do special operation to extract this wood from the forest. And these special operations displace the plant management. So there is also an effect on the long-term goals of the management plans that get shifted, and then when do we go back to harvest these woods and so on. So there are a lot of consequences also that are reflected in the management.
Great, thank you very much, Marco. Does someone have a question over there?
I don't think I have a question, but I have a comment. I think we are slowly reaching the end here, and before that, I would like to thank EFI and not least all the young scientists here for making these things here. If you think about that, never in the history of mankind has forest played such a big role for society to solve all kinds of problems, including problems we have made ourselves. The climate problem, the biodiversity problem, the clean water problem, and so on and so forth. So there's definitely need for young and new and bright scientists to tackle all these things. So for me, at least, not to close the whole thing, but for me as an elderly gentleman here in this room here, and with a long tradition also, I'm so delighted to listen to you guys, and thank you very much from my side. Yeah.
Thank you for your enthusiasm. It's really great to be here. Does someone we have time for a last question for the audience.
I also thank you so much for this panel, also previous presenters for framing these issues and the many challenges around climate-smart forestry and sustainable forest management in general. I have a rhetoric question for you and for the audience, is that are you ready to move this knowledge into action? Are you ready to solve today some critical gaps and barriers that we have identified in our regional network to implement carbon farming and climate-smart forestry, maybe to improve our capacity to forecast, monitor early warning and response when we have decays and bark beetle other disease, or to leverage the power of non-forest products for, in support of forestry? If so, we invite you to consider our Open Innovation Challenge, so that you have the leaflet down there. We are ready to, we will select some winners of concrete solutions. If you read the pamphlet and our web companion, you will see that many of the issues you have touched have identified as critical issues already, but they need an answer today. How we incorporate carbon soil into carbon markets now. Do you have a solution? Do you think you have it? Come to us, and then we offer you a grant, possibility to test your idea, to meet the regional partners, maybe to make a business, to expand, to find partners, to find a job, whatever. So this is our pilot. We invite you to join us for this game, to meet our challenge owners, you as solution providers. And stay tuned, because next year we will be tackling in a more ambitious challenge together with CTFC and other actors, tackling specifically wildfires. So we'll take this as a pilot, as a first test, and we'll come back to you with more structure and scaling up this type of tool to put knowledge into practice. So thank you very much.
Thank you very much, Ignacio. Now to close the panel, as we are running short in time, I would ask our panelists to give a final statement, and I would really like for you guys if you could retain yourself in only a few words, so we don't don't run on the time. So for Anthony Margarida, I would like, as you're here representing more the senior part of the panel, I would like to ask you. Sorry.
We are the other age classes. We thought we were younger.
Okay, everyone here is young researcher, don't worry. So, but some young with a little bit more experience than other young researchers. But for you and Margarida, I would like to ask you, like, what do you think is the most important aspect under the climate-smart forest to reach climate neutrality? Maybe, Anthony, you can start?
I think from the science point of view, we do not know everything, but we have quite good basis for making reasonably good proposals. So I think the main business is in changing legislation and policy-making mechanisms, existing ones. There is much to do in Brussels, and I think EFI as a network can go there and at least below this Green Deal umbrella, the different strategies, biodiversity, forest, bioeconomy, all that to create a good coordination. If that is done, then we are closer, because from that umbrella, then we will go to state and then regional level with a stronger framework arguments for implementing that. So for the short term and for keeping it short, I think there is much potential here with changes in legislation and rules, and as well these public-private frameworks, really to be ambitious and go for the main league, you know, with the big companies, with the Commission, the states, and try to do something which can really have an impact.
Okay. Thank you very much. Margarida, for you, what would you think is the most important aspect under climate-smart forest to reach neutrality?
I think I will copy EFI. I will say that the most important is to put science into action, to find ways to put science into action. And this is not easy. We have to work a lot with stakeholders. And we have to find ways of governance, because I think that one of the biggest problems, at least in Portugal, is to find ways to make attractive for the landowners to implement what we already know, because we know, I was telling that management is difficult, but we know something. So there's a lot of knowledge that we could put into action, but we have to find ways to do it. And I think this is quite important.
Yeah, EFI slogans are really good.
I think it's a good one.
Now, to ask Mariana and Marco, as you're representing more young side of researchers here, in 10 years from now, what are we going to be talking about climate-smart forest? Mariana, can you start, please?
In 10 years, well, I think one of the things is that we have to avoid having this tunnel vision on carbon. So we have to think more towards improving forest health, resilience, taking care of the biodiversity. So this is maybe something that I personally would like to see in the next 10 years. So it's really improving the forest conditions so they can be resilient in the long term, and not only focusing on carbon.
Right, thank you. Marco?
I would like to change a bit your question, because I think Mariana already covered very nicely. And I would like to shift the focus on not on what we are talking about, but who is going to talk about climate-smart forestry. And this, I think, it fits very nice with this panel, because thanks to the Institute and to the people who organized this, and to give the chance to all my colleagues and myself to take part of this. I think, as have been said throughout the day, the sector is on a transformative path, and there is a lot of need to have an impact, and we all want to have an impact. And I think involving the young scientists into this process of making changes to the system, it will contribute to build a future generation of impact-driven scientists, which will make a difference in 10 years and to push the agenda according to what we want to achieve.
Yeah. Very well put it, Marco. So now we come to the end of our panel, and I would like to ask for, give a hand for our amazing panelists today. I also would like to thank EFI for the opportunity. As Marco said, it's really important to bring the young researchers and put them in the conversations of what we are going to face in the future. So now I would like to ask Hallberg to come here to say a few words. And that's it. Thank you, guys.
So now it's again the turn of the more experienced ones to close this, and two announcements. First is just to let you know that this whole afternoon program was actually designed by the young colleagues that you saw. So I will start here with Mariana, Marco, Yasmin, Sara, Bas, whom did I forget? I think it's everybody I mentioned. So, and even though there were other older colleagues at some point involved, I think that it's really the applause for them to have done this. As EFI, we are very happy to see it, because I was just saying yesterday that in one of the conferences I was sitting in the back, and when you look down, they were all either bald or gray. So I think we have to change that diversity a little bit. And so I think that we organized this also as a grant. So we actually made a call. We received several more proposals than what we could accommodate. So, of course, and we selected 5 really excellent young scientists that really gave a very good presentation. So based on this experience, I can tell you that next year we will at least repeat this, if not even improve it in one or another way. So any proposals or suggestions from your side are very welcome. So, but once again, thank you, guys, and also thank you to their mentors that they allowed them to be here. Actually, I think that this is also an important, so really excellent. And now the final word of wisdom at 7 o'clock, drink and a little bit relaxation here in the garden, and then 7:30 we will move up into the, to having a dinner. So see you back here at 7 o'clock. Now relax a little bit in the meantime, and then tomorrow morning 9:30 is the start of the scientific conference. It's not here, it's in the Museum of Design of Barcelona, which is in the Plaza Glorias, no, is it, Mark? And so be there a little bit earlier. I mean, at 9 o'clock, because there will be a lot of people. This today is only a fraction of what will be there tomorrow. So be there on time, that our colleagues have also enough time to register you, to let you in. So, and see you tonight then. Thank you very much, everyone. Thank you.
Tinha um mosquito me picando embaixo.